Good morning, grade 9. This is Mr. Eza. This is a video guide for the Good morning, year 9. This is Mr. Eza. This is a video guide for the standardized test practice chapter 3 accelerated motion. I hope you try to answer the practice paper independently before watching this video. Question 1. Graph the following data and then show the calculations for acceleration and displacement after 12 seconds on the graph. So the table is given, and as you can see, I've already graphed the points. And first, we're going to calculate for acceleration. Okay, this is a velocity time graph, VT graph. So if we have a VT graph, the acceleration is equal to the slope of the graph. Okay, I'm just going to draw a line of best fit for our graph. This is our line of best fit. Now I'm going to calculate for the acceleration. I'm going to choose 2 points for the slope. So let's choose these points. This one, 40 and 72. Okay, these are the corresponding points. The y2 will be 72 and the y1 is 40. x1 will be x2 will be 12 and x1 will be 6. Okay, so the acceleration is equal to the slope. Therefore, acceleration is equal to y2 minus y1 over x2 minus x1. Now, substituting the numbers, 72 minus 40 divided by 12 minus 6. 72 minus 40 is equal to 32. Okay, and then 12 minus 6 is 6. 32 divided by 6 now is equal to 5.33. So the acceleration of this is equal to 5.33 meters per second squared. So remember that if you have a VT graph, the slope is equal to the acceleration. We're going to solve displacement on the next slide. Okay, continuation. Same question, but now we're going to solve for displacement. Now remember that in a VT graph, this is a VT graph still, same graph, VT graph. If we want to solve for the displacement, okay, wait please. If we want to solve for the displacement, it's equal to the area under graph. Okay, so you have a VT graph again. The area under the graph is equal to the displacement. So we'll just mark the area under the graph. We have this shape over here and another shape. I'm going to use another color so that we will distinguish the two shapes. This is the other shape. Okay, so there are two shapes. One is a triangle and the other one is a rectangle. So first we're going to calculate for the area of a triangle. This is the triangle. The formula for the area of the triangle is equal to A is equal to 1/2 times base times height. For the rectangle, the area is equal to length into width times width. Okay, let's substitute the values. Area of the rectangle is A is equal to 1/2 times base. Let me just use another pen so that it'll be smaller. Wait please. Okay, let's use this pen. Okay, area is equal to 1/2 times the base. Base is 12. Multiplied to the height. The height starts at 72 and ends at 8. So 72 minus 8 will be actually 64. So using your calculator, the area of this triangle is equal to 384 meters. Okay, and then how about the area of the rectangle? Area of the rectangle is equal to length times width times width. The length is 12, the width is 8. 12 times 8 is 96 meters. Okay, it's equal to 96 meters. So we have two areas, 96 and 384. We'll just have to add the two areas, area 1 plus area 2, area of the triangle and the area of the rectangle, which is equal to 480 meters. So this is the displacement of the object. Again, I'm going to tell you that if it's a VT graph, the area under the graph is equal to the displacement. Next question. A bicycle accelerates from 0 meters per second to 4.0 meters per second in 4 seconds. What distance does it travel? So first we're going to list our given. VI is equal to 0.0 meters per second. Initial velocity, because it accelerates from 0.0 meters per second. How do we know that this is velocity? Because the unit is meters per second. And then we have the word accelerates over there. Okay, let's talk about that later. And then we have this velocity. Since we have the initial velocity, of course it follows that's the final velocity, which is equal to 4.0 meters per second. And then in 4 seconds, it means that that's your final time. TF is equal to 4.0 seconds. So we're going to assume that TI initial will be starting from 0. Of course, all time will start from 0.0 seconds. Now the word accelerates, it's there. So it means that we can solve for the acceleration of this problem. What's the formula for acceleration? Acceleration is equal to VF minus VI divided by TF minus TI, which is already given. Okay, these values are already given and A is missing, so we can solve for A. Now substitute the values for A, for VF and VI I mean. Okay, VF is 4.0 minus 0.0 divided by, again, 4.0 for the time minus 0.0. So your acceleration is equal to 1.0 meters per second squared. So you have all your given over here. We have, let me just change the color so that we will distinguish, VI, VF, TF, TI, and A. All of these are given. Now we need to find the distance that it has traveled. So in this case, we will find for XF. Okay, what is XF? It's unknown. And then we have to assume that it has started at the origin. So XI is 0.0 meters. Okay, so we also have that value, XI. Now, which of these formulas given over here will fit the given of our problem? So the second formula over here, it's given that XF is equal to XI plus VI multiplied to TF plus 1/2 A TF squared. Do we have XI? Yes, we do. Do we have VI? Yes, we do. TF, of course. A is now solved. We have solved for it and TF is given. So we can assume that we can safely use this formula. Okay, so let's list it down. We're looking for XF. The formula is equal to XI plus VI TF plus 1/2 acceleration, average acceleration TF squared. Okay, XI is 0 plus VI is also 0, initial velocity, multiplied to TF, which is 4, plus 1/2, this 1/2, multiplied to A, which is 1.0, times time, T2, TF, this is TF, okay, TF is 4, then squared. Okay, using your calculator, of course, you'll be able to get the answer as 8.0 meters. And that's it for this problem. Next question. A weather balloon is floating at a constant height above Earth when it releases a pack of instruments. A. If the pack hits the ground with a downward velocity of 73.5 meters per second, how far did the pack fall? And B. How long did it take for the pack to fall? First and foremost, this question is all about acceleration due to gravity free fall. Alright, so if we have a free fall, we know that A, the acceleration is always equal to negative 9.8 meters per second squared. What else do we know? In this case, if we are going to draw, this is your weather balloon above the earth, and then something will fall and it will go down. So initially this will be our xi, position 10 meters, and then xf over here. Okay, we don't know how far it fell, okay, because that's the question. And then of course the v over here will be a negative v. Why? Because the downward it's a downward velocity. Okay, so whatever v given here will be negative. But our vi, what is our vi if it just dropped? Okay, so vi will be equal to 0. All right, so we have vi, initial velocity will be 0.0 meters per second, and then vf, according to the problem, vf is 73.5 meters per second. We're going to denote it as negative 73.5 meters per second, the negative being the direction, which is downward. Now xf is unknown. We have to find xf. Now xi, we start at 0 from where the weather balloon is. We're going to solve A in this slide, and the next slide we're going to solve for B. Okay, for A, now which formula are we going to use from these list of formulas over here? Okay, so we have A, we have VI, we have VF, and we need XF. We also have XI. So which formula are we going to use? We can safely use the third formula over here. VF squared is equal to VI squared plus 2A multiplied to XF minus XI. Why? Because it fits all the given. All the given will be here. Okay, VF is negative 73.5. Now you have to square that, is equal to VI, which is 0, squared plus 2 times A, 2 multiplied to A is negative 9.8 meters per second squared, multiplied to XF, we don't know XF, minus XI, which is 0. Alright, so 73.5 squared negative 73.5 squared is equal to 5,402.25 is equal to 0 squared is 0, so I'm not gonna write that anymore. 2 times negative 9.8 is negative 19.6, and then XF minus 0 is just XF, so I'm just gonna write XF over here. Next step, we're going to divide both sides by negative 19.6, then negative 19.6, so that we will leave out XF on one side only. Therefore, the final answer, if you're going to use your calculator, XF is equal to negative 275.625 meters. Okay, now you're going to write it as scientific notation, so the XF is also equal to negative 2.8 times 10 raised to the positive 2 meters. Now you have to write it in scientific notation because we have to follow the least scientific significant figure, which is 2. This is also 2 significant figures, so that's the smallest significant figure in all you're given. Therefore you have to follow that. Negative 2.8 times 10 raised to 2 meters. You can also write your answer as, I'm gonna write over here, xf is equal to 2.8 times 10 raised to positive 2 meters downwards. If you don't want to write the negative sign, then at least write downwards as your direction, because negative already denotes downwards direction. Now we're going to solve for letter B. How long did it take for the pack to fall? Again, we are going to list all the given that we have over here. The VF is equal to negative 73.5 meters per second. Earlier we said that the VI, initial velocity, is equal to 0 meters per second. And of course we already know A is equal to negative 9.8 meters per second squared. In this problem, how long means T, delta T. Okay, what is delta T? Which formula has all of these givens? We have the first formula, VF is equal to VI plus A delta T. Okay, so VF is equal to VI plus A delta T. There's nothing special about choosing the correct formula. You just have to look at your given. Which of these formulas fit your given, then you have to choose that. Alright, so VF is negative 73.5 is equal to VI is 0. So as you can see, all of the given are represented. So I chose this formula, plus A is negative 9.8 and delta T is what we're looking for. Okay, or TF minus TI. That's the same as delta T. Okay, so negative 73.5 is equal to, I'm not going to write 0 anymore, negative 9.8 delta T. We want delta T on one side, so we're going to divide both sides by negative 9.8, negative 9.8. So we can cancel out negative 9.8. Now we're going to use your calculators to solve for 73.5 divided by 9.8 to get delta T as 7.5 seconds. And that's the final answer. Next question. You throw a beanbag in the air and catch it 2.2 seconds later at the same place at which you threw it. A. How high did it go? And B. What was its initial velocity? Okay, so here's a beanbag. You throw it up over here and it reaches this height, and then it will go back down in 2.2 seconds at the same level that you threw it. So it means that for this first part of the journey, 1, and then the second part of the journey over here, 2. Okay, the time it takes here from the initial position to the final position XF over here is 1.1 seconds. And the time it takes from the XF going back down to XI is also 1.1 seconds. Okay, so this part of the journey is 1.1 seconds, and the second part is 1.1 seconds as well. That's why it's 2.2 seconds over here. Now we don't know XF, but of course XI will be equal to 0 meters. That's where our starting position is. We always assume that it is 0. Okay, what else do we know? At the highest point over here, the blue ball, okay, the V over here, the VF is equal to 0 meters per second. Why? Because it will stop for a little bit and then it will start going back down again. But in here, the VI, we don't know that. So let's solve for the VI first, although that's the second question, that's the letter B question, because I want to solve VI first because that's we need that for solving letter A later on. Okay, so VI is unknown, so the formula that we're gonna use for that is this one: VF is equal to VI plus A delta T. Now A, as you know, is always equal to negative 9.8 meters per second squared. So letter B first, we're going to solve that. VF is equal to VI plus A delta T. Okay, so the delta T that we're going to use will be 1.1, not 2.2, because we're just going to solve for one part of the journey. Okay, so the VF, as we know, as it reaches the top is 0, is equal to VI. VI is unknown, we're looking for that, plus A, which is negative 9.8, and delta T is 1.1. 1.1. Wait, please. 1.1. Okay, so negative 9.8 multiplied to 1.1 is negative 10.78. Then VI is still here, equal to 0. We're going to shift VI to the other side. It's positive now, so if you shift it, it'll become negative. VI is equal to negative 10.78. Okay, now they're both negative, therefore VI is equal to 10.78 meters per second. It's positive, therefore direction is upward. So that's letter B. Now we're going to solve for letter A. We're going to solve it in the next slide. Okay, in the previous slide we solved that VI is equal to 10.78 meters per second. Alright, now we're going to solve for letter A. How high did it go? We're going to solve for XF. Okay, XF is unknown. Now which formula will fit all the given that we have in this problem? We're going to use the formula XF is equal to XI plus VITF plus 1/2 ATF squared. Why? Because we all have the given, okay, in this problem. So let's just write that down. XF is equal to XI plus VITF plus 1/2 ATF squared. Okay, XF is unknown and XI is 0. From here, this is 0 plus VI. Now we have solved for it in the previous slide. Equals 10.78 meters per second, and TF will be 1.1 as well. 1.1 in the other side, so it's still 1.1 plus 1/2 multiplied to A, which is negative 9.8, multiplied to 1.1 again. Okay, using your calculator for all of these, XF will be equal to 5.929 meters. Okay, we only need two significant figures, so we're going to round up our answer to 5.9 meters. So this is the final answer for letter A. How high did it go? Next question. Suppose a spaceship far from any star or planet had a uniform forward acceleration from 65.0 meters per second to 162.0 meters per second in 10 seconds. How far would the spaceship move? Okay, we have, it says forward acceleration over here, although the acceleration is not given, but we'll be able to solve for it. Okay, so first we have 65.0 meters per second. So that's our initial velocity. Vi is equal to 65.0 meters per second. And then we have 162 meters per second. That's our final velocity. 162.0 meters per second. And then we have either 10 seconds as our delta t time interval, or tf minus ti, ti being 0, tf is 10, so it's still 10.0 seconds. Then how about a? What is our acceleration? Acceleration is not given, but we can solve for it using the formula. A is equal to, let's solve over here on the space, so we have another space for later. A is equal to Vf minus Vi over delta t, or Tf minus Ti. In this case they're equal, so I'll just use delta t. Alright, so A is equal to Vf minus Vi. Vf is 162.0 minus 65 divided by 10. A is equal to 9.7 meters per second squared. Okay, I hope that's clear. So I'm just gonna list it here. A is equal to 9.7 meters per second squared. Okay, now how far would the spaceship move? We need xf. Okay, using these given Vi, Vf, delta t, and A, which formula would fit this question? So the formula that we're going to use is the second formula over here. Okay, xf is equal to xi plus Vi multiplied to tf. Okay, tf being 10 seconds, still equal to delta t because we started at 0 time. Therefore, tf minus ti is equal to 10, and it's still equal to delta t plus 1/2 a tf squared. Alright, xi. What is xi? We are going to assume that started at the origin. Of course, that would be 0. Plus Vi. Vi in this case is 65.0 multiplied to TF, which is 10, plus 1/2. Acceleration is 9.7 according to our solution to our working, multiplied to TF, which is 10. Then you're going to square it. Do not forget the square. Using the calculator, you're going to get the answer 1135 meters. Now we only need how many? We need 3 significant figures. Over here it has 3 significant figures. Although 9.7 has 2 significant figures, we're not gonna follow that because that's not a given. We solve for it, so we need to change our answer to 2 significant figures. It will become 1.14 times 10 raised to the power of 3 meters. So this is your final answer. Next question. Rock A is dropped from a cliff and rock B is thrown upward from the same position. A. When they reach the ground at the bottom of the cliff, which rock has a greater velocity? B. Which has a greater acceleration? And C. Which arrives first? Right, we're going to draw first so that we will understand the situation. This, let's say this is the cliff, and we have 2 rocks. They are going to start from the same position. Rock A and rock B. Rock A is just dropped from this position. Okay, so from that position it will just go down like this. Rock B, however, is going up first, and then as it reaches this position, then it will start going down. All right, so for rock A, the VI initial velocity is 0, but for rock B, VI is not 0. It has an initial velocity which is greater than 0. VI is greater than 0 meters per second. Therefore, it already has a starting velocity, then it will have a greater velocity in the end. Okay, so but the question, letter A, when they reach the ground at the bottom of the cliff, which rock has a greater velocity? Okay, so for letter A, the answer will be rock B will have a greater velocity. Okay, because as it goes up from the original position to the highest position, and then it will go down from there, it will attain a greater velocity as it goes down, because now it will start from a higher position than the rock A. Okay, for letter B, the question is, which has greater acceleration? Okay, rock A acceleration will be equal to rock B acceleration. Why? Because only the acceleration due to gravity will be acting on both of them. All right, and then letter C, which arrives first on the ground? Of course, rock A. Why? Because rock B will still have to cover a certain distance going up before going down. Therefore, rock A will arrive first. But if they started at the same position, of course, they will arrive at the same time. Even if they have different masses. Let's say rock A has a greater mass than rock B, but they started at the same position, they will arrive at the same time. But in this case, they will not arrive at the same time. Rock A will arrive first because rock B will still have to go up and then go back down. Extra question. A driver of car enters a new 110 km per hour speed zone on the highway. The driver begins to accelerate immediately and reaches 110 km per hour after driving 500 meters. If the original speed was 80 km per hour, what was the driver's forward acceleration? All right, so our VI here is equal to 80 kilometers per hour. We're going to change this to meters per second. Why is it that it's the VI? Because it says here original speed. All right, so we're going to change this to meters per second. So we're going to have to multiply it to the conversion factor for kilometer to meter, which is 1,000 meters is equal to 1 kilometer. And the conversion factor of the time, 1 hour, is equal to 3,600 seconds. Cancel hour and hour, and kilometer, and we will get 22.22 meters per second. That's for VI. For VF, okay, it's 110 kilometers per hour. Again, using the same conversion factors, then we are going to get the meters per second of this. 1 hour is equal to 3,600 seconds. Same steps. Kilometer and kilometer cancelled, hour and hour cancelled, and using our calculators again, we are going to get 30.56 meters per second. We have our XF, although it's not mentioned over here. Okay, oh, it's mentioned. As a matter of fact, XF is equal to 500 meters per second. What's not mentioned is the initial position, which is always equal to 0 meters. If it's not mentioned, we are going to assume that it started at the origin, so 0 meters. Now we're going to find for the forward acceleration. Okay, so using our given and we have to decide which formula we're going to use, and it will fit the formula VF squared. VF squared is equal to VI squared plus 2 multiplied to A times XF minus XI. Okay, now we're going to substitute our given. VF is equal to 30.56 squared is equal to 22.22 squared plus 2, and A is unknown, multiplied to 50 for the XF. Then XI is 0, so we don't need to write it. Okay, simplifying this, we're going to get 933.913636 is equal to 493.7284 plus 100A. 1000A, it's not, is it? 2 times 50 is 100. Alright, and then again we're going to get 933.9136 minus, we're going to transpose 493 to the other side, will become negative 493.7284 is equal to 100A. Okay, we're going to continue here. So we're going to get the answer 440.1852 is equal to 100A. Divide both sides by 100, so you'll get A equals 0.44 meters per second squared, and that is letter A. So that's it for this video. Good luck to your exams. All the best.